Hey guys, welcome back. It's Mr. Marone here. Today we're going to wrap up our discussion on transformations and take a look at dilations in the coordinate plane. Okay, so we've looked at slides, we've looked at flips, we've looked at turns. Now we're going to stretch or shrink a figure. Okay, so a dilation, just like if you think about going to the eye doctor and getting your pupils dilated, making something, dilating your pupils is making them bigger. So think of it that way. So a dilation is going to be the shrink. Oopsies, wrong tool here. The shrink or stretch of a figure. Okay, so the shrink or the stretch of a figure here. That's what we're looking for. And in this case, we're going to be given a variable, okay, which is going to tell us what's called the scale factor, what we're going to stretch or shrink by. Okay, so we're going to have a scale factor. And we're going to use the letter K here. You'll also see, I'm going to put in parentheses, you'll see a capital D there as well sometimes. Okay, you'll see K or you'll see D. Now, when that number K is bigger than 1, then the dilation is going to be a stretch. Okay, we're going to make the figure larger. When K is less than 1, which I will say is usually a fraction, so I'm actually going to make it between 0 and 1. If K is between 0 and 1, then we're going to have a shrink. We're going to make it smaller. Okay, so that should be your indication. If you have a K factor of 1/2 or 1/4, that's always going to make it smaller. Okay, and just like before, our original image is our pre-image right here, and our newly created figure is going to be our image right there. So let's take a look at an example. So here we've got triangle RST, and they gave us our scale factor of 2. Because that's larger than 1, we're going to stretch this. And what you're going to do is you're going to multiply each value, each point, each coordinate, your x and your y of each figure, and you're going to multiply each of them by the scale factor. So in this case, if r is -5, 1, it's going to become -10, 2. We're going to double each one. Same thing for s and for t. S becomes -6, 8, and t becomes 4, -2. Okay, and you're just going to expand each of these. So if we were to then graph those points, we've got 10, 2. This point out here becomes r prime. And as I'm graphing these, just something to think about here is you're going to have a totally different look to the figure now. Okay, so we've got r prime and s prime drawn in already. And as I draw in t prime, just to think about it, before with our flips, our stretches, or I'm sorry, our flips, our rotations, and our slides, we had the same exact figure. They were congruent figures. Okay, here we're going to now have brand new figures. It's going to be the same exact shape, but it's going to be larger or smaller. So before we were able to have a different size, here we're going to have something totally different now. So just keep that in mind as we work through these. So I'm just going to draw in a couple lines here, just so we have our new figure. Okay, so I've got r prime to s prime, I've got r prime to t prime, and I've now got t prime to s prime. So as you see, the figures look a little bit different around here now that we've got our stretch here, our stretch of factor of 2. If it was a shrink, it would be much smaller. They are similar figures, so we haven't changed the makeup of the figures so much. We've just doubled it in size. It should look similar, but it's not going to be exact as it was with the rotation, the reflection, and the translation. So keep that in mind as you work through these. So try the rest of those problems on that page in your packet, and I'll answer any questions you guys have in class tomorrow. Have a great day.